Hey guys, my name is Danny Zuniga and I'm participating in Challenge of 2014. These are all my study buddies, check them out. Oh yes. It's time for some calculus though. Alright, so we're gonna find local extrema and the equation that we're given is f of x equals x plus 1 over x. So that's the first line up there. And then I just translated that into a simpler form that I could work with for derivatives, and that's x plus x minus 1 right here. And then first off, to find the extrema, you take the derivative of the equation. So that's my first step right there. So the derivative is 1 minus x to the negative second. And the reason we do that is because we move the power down, so we multiply by negative 1, and then we subtract them from the power, so that's where negative 2 came from. Now we transfer that into a form that's easier to solve for equations, which is 1 minus 1 over x squared. Now the important part for finding a derivative is setting that value equal to 0. So if your derivative is equal to 0, that means that there must be a local extrema at that point. So that's what I wrote over here. 0 slope indicates an extrema. So we said 0 equal to our derivative, which is 1 minus 1 over x squared. Now we move the 1 over x squared to the other side, and I did that right here in this step. And then we multiply by x squared on both sides, and we have x squared equals 1. And then you take the square root, and you get x equals positive or minus or negative 1. And that's where our extrema are located. But what type of extrema we have, it depends on our second derivative test, which is performed down here. So starting the second derivative test, we take the second derivative of our first function, which was x plus 1 over x. And we take the derivative of that, and we got 1 minus x squared. And now we take the derivative of that, and we get 2x to the negative third, or 2 over x cubed. Now, what we're going to do with this function is we're going to plug in our extrema into this second derivative function right here. And if we get a number greater than 0, we have a minimum. If we get a number less than 0, it's a maximum. So that's what I perform right here. So for the x equals 1 extrema, we do 2 right here over x cubed, but x here in this case is 1. So 2 over 1 cubed, that's obviously 2 over 1 is 2. So 2 is greater than 0, so we have a local minimum at x equals 1. And then at x equals negative 1, we plug that one in, and we get the same sort of line here. We put a negative 1 instead of 1, and that gives us a negative value. So negative value is obviously less than 0, and that gives us local maximum. And now to prove this, we go down to our, you can graph the function, and this will just be a little proof. So you got f of x equals x plus 1 over x. So if you graph that here, it's going to look like that. So it's not, we know, I assumed it was local minimum. You can't just assume it's a local maximum or minimum just based on the question, find the local extrema. So in order to find out whether it's local or the absolute maximum or minimum, you have to graph, and that's what I did here. And we know that there's a minimum at 1, that's it here. Minimum at 1, maximum at negative 1. So we look for it on the graph here. We have a minimum here because it's concave up, and that's a bottom point. But it's not the absolute minimum because we still have graph beneath it. So then also here we have a maximum because it's concave downward, and that's the topmost point, uppermost point. And then it's also not the absolute maximum because there's a graph above it. And so that's how you find your local extrema at x equals 1 and x equals negative 1. Thank you guys for watching. And for Danny and all his study buddies. Yeah, oh, they're not watching. Okay, we're out. Thanks, guys.